Hello, this is Carlos Agarra and I am going to show you the modeling process to develop a machine learning model to solve a simple problem. I will show you how I built a model to predict the electrical energy output of a combined cycle power plant which uses a combination of different sources to generate power. To solve this problem, we had more than 9,000 sensor readings from the power plant, like ambient temperature and electrical energy output. Since we need to predict the energy output based on past observations, this is a regression learning task. In addition, in the session you will see 3 different models and how I selected the one with the best performance to make predictions. To do that, I used 2 output metrics, mean absolute error and root mean square error. Because feature selection is critical in the modeling process, I used a heat map matrix to see the correlation between features and the output variable. Therefore, the models I created have the combination of features as you can see here. Finally, in terms of the algorithms to use, regression tasks belong to the supervised learning type of machine learning. So we have many options like linear regression, decision trees, or random forest. However, because I am using Excel to create the models, my option was the multiple linear regression algorithm. To compare and select the best model among the 3 I created, I divided the dataset into 3 groups: 70% for training the models, 10% to validate their performance and select the best model, and 20% to evaluate the performance of the final model. Let's look at the models. This is model 1 with 2 input variables and the output variable. The first thing I did is to use the option data analysis regression and specified the parameters and where was going to be the result. From this section in yellow, I made explicit the model and used it to predict the values on the validation set. Here's the validation set, and as you can see on the right, I calculated the error, absolute error, and square error. If we go to the end, this is the metrics, the output metrics for model 1. I repeated the operation, the same step for models 2 and 3, and you can see at the end of this the comparison between the 3 models. As you can see, the model 3 has the best performance, meaning that its predicted values were on average less away from the actual values for the mean absolute error, and that in average model 3 makes a smaller error in predicting a value for an observation for the root mean square error. Therefore, we can say that model 3 is our final model and can be evaluated against the test set. However, before we need to retrain it using the training set plus the validation set. So I conducted a new regression and then I used the results. As you can see here, I used the results to predict the energy output for the test set. As you can see, the model 3 retrained had an even better performance predicting values using the test set. That's the bibliography, and I hope you find this video useful.